Is this a D value or a C value in that y equals a sine B? Is that 3 a C or a D? It's a D because it's not in brackets, so it's your D. So what transformation is that? Vertical translation 3 up. So if it's vertical, it's not with the x. If it's not with the x, it doesn't affect the x. So it only affects the y's, right? Which following things are affected by y? Is amplitude y? Yes, because it's how far you vertically distance half the distance from min to max. So amplitude will change. Would your range change? Actually, would your amplitude change? You're taking the graph and you're shifting it 3 up. Are you making it any taller? No. So your amplitude doesn't change. What only affects the amplitude? The stretch. The vertical stretch is the only thing that affects your amplitude, right? Because we're literally just taking the exact same tallness of a graph. Tallness, I'm going to use that. I don't know if that's a word. I'm using it anyways. We're going to take that same graph and we're just moving it up. So we're not actually making it any longer. We're not stretching it, right? So vertical stretch affects your amplitude, which makes sense because your A is your amplitude, right? Which is also your vertical stretch. Does your range change if I move it up 3? Yeah, it's going to move it up 3, the whole thing. So it'll change your range. Will the period of the graph change if I just move it up? The period's only affected by the x, or the what? Horizontal stretch. Because the horizontal translation, will that affect how often it repeats itself? No, you're just moving it left and right. Okay? So the period's not affected by this. Is the domain affected by this? No. X-intercepts, if I move it up, would that change my x-intercepts? Yeah, because wherever they would be on the x-axis, I might even move it completely off the x-axis, right? So it will affect your x-intercepts. So remember, once we start doing combos, you might say, oh, it doesn't affect the x, but it might, because it might just pull the whole thing up off of the x-axis, right? And y-intercept, will it change it? Yeah, it'll take wherever it is and it'll shift it up. Now the range, remember I told you, it's just d plus the amplitude? Why is that? Okay, so go and put y equals sine x into your calculators, the basic y equals sine x. And then put it in either degree mode or radian mode, I don't care. Okay, your choice. And then I would zoom trig it so that you actually have some sort of a graph being drawn. Okay, do you have the basic sine x showing up? If you don't, go zoom trig, because whatever mode you're in, it'll at least make a window that you can see it. Okay? Then in y2, you can make it thicker, or change the color if you have the color one, which is awesome. And you're going to put in sine x plus 3. But what do you have to remember to do? When you type sine x, you have to close that bracket, right? Plus 3, or it's going to assume the 3 is with the x. You have to close the bracket behind it. Into y2. Then press graph. So the whole thing shifts 3 up, correct? Now, the d value of the first one, when we put in y equals sine x, what's my d value? 0. Where is this graph? Where's the middle of this graph horizontally at? The first one. Y equals 0, the x-axis, right? It's completely the same. It's symmetrical about the y-axis. It's the same amount of the graph above as the graph below, correct? That's called the midline. So your midline is actually your d value. It's the midline or the median value. It's the middle, okay? So your d is always your midline or your median value. I'm going to write this. So in the case of y equals sine x, it was y equals 0 as my median value. That's the middle of my graph, right? It occurred on the x-axis. Now, the second graph, y equals sine x plus 3, where's that midline? At y equals 3. If I look at y equals 3, it's the same amount of amplitude up as it is down. It's 1 up and 1 down, correct? So the midline of this one is at y equals 3. That would be my midline, right? Well, if I take that midline value of 3, I'm going to draw it down here. So if I take the midline value of 3, because it's y equals 3 for that graph, what was the amplitude for that graph? What's my a value? It's just 1, correct? So if I go from that midline and I go up 1, because that's my amplitude, and I go down 1, because that's my amplitude, what's the highest I get to? 4, and what's the lowest I get to? 2. So I have my min and my max. I don't actually have to even plot it. I don't have to graph it. So that's why I've said before in the previous day that if I take the D value, so for the minimum, if I take my D value, which is my midline, and I subtract my amplitude, I'll always get my min, right? And for my max, if I take that D line, that amplitude, and I add the D line, which is my midline, sorry, and I add my amplitude, I'll get my max, right? Because the D is the middle. If I add the amplitude, I get to the highest. If I take that D value and I subtract my amplitude, I get to the lowest, correct? So in this case, my D value, you guys said, was 3, and I subtracted 1, so I get 2. This one, it's going to be 3, and I add 1, so I get 4. So my range would be between 2 and 4. Now some people say, well, I can just go second trace max and find it, second trace min and find it. Yeah, you can, unless I give you an equation that has all variables and I ask you for the max and min or the range. So for an example, I could give you this. Y equals a, let's use a different letter than a. Y equals m sine 2x plus pi minus k. What's my range? Can't plug that into your calculator, right? Well, range is just from min to max, correct? Just from min to max. So what's my median line in this case? What's the middle of my graph at? The negative k, right? It's down to the bottom. So my minimum would be negative k. So that's where my middle line is. And my max would be negative k, because that's where my middle line is. But for the max, I add my amplitude. And for the min, I subtract my amplitude. So say I even make this be a negative m. Let's make it a little more complicated. If it's a negative m, what's my amplitude? M. Because the amplitude is a distance. It's positive. The amplitude is the absolute value of a, whatever this a is. And in this case, the a is negative m. But the absolute value of negative m is m. Okay? So for my max, I'd add my amplitude. And for my min, I'd subtract my amplitude. So what's my range? Well, I can do it in 2 ways. I can go min, like this, to max. Or I could do y such that negative k minus m is less than or equal to y is less than or equal to negative k plus m. Right? So you have to be able to solve this without having numbers. You have to be able to find mins and maxes from an equation. That's what I'm saying. Because I've seen it numerous times where you can't plug that in. I have 2 variables. What are you going to do? Right? Actually, I have 3 because I have an x as well. Okay? So very important. Make sense? So if we look at number 2, what's my transformation? Vertical translation 2 down. What's my range in this case? Well, I get my min. What's my d? What's my min? Or my d value? My midline? Negative 2. And for my min, I'm going to subtract my amplitude. And for my max, I'm going to add my amplitude. What's my amplitude? It's just the absolute value of a. What's a? 1. The value here. So it's going to be from negative 3 to negative 1. Right? Number 3, what's my transformation? Vertical stretch by a factor of 3 about the x-axis. What is the vertical stretch effect? It affects the amplitude, because it's going to make it taller or shorter. It affects the range, because it's going to make it taller or shorter. Is it going to affect the period, the width-wise, or the domain? No. Is it going to affect my x-intercepts where they occur? It could. It didn't yesterday because we always had a midline at 0, correct? But if our midline is up and I stretch it, well, can I pull it away from the x-intercept that it was normally at? Yeah. So if I actually have a midline that's not 0, it will affect my x-intercepts and my y-intercepts. Okay? And then what's the range of this graph? Well, we do our max. Oh, this is also another transformation. What is it? Vertical translation to up. So it's my what value? My d value, which is my midline, or my median value, right? So if I do my minimum and my maximum, it's going to be at d, so 2 for both of these. That doesn't change, right? The d doesn't change. But you're going to add your amplitude for your max because you can go from that d line up, d line down. So add my amplitude. What's my amplitude for the first one? 3. Actually, what's my amplitude for both of them? -3. So this can be -1, 2, 5. Make sense? We're going to go down to number 5. Number 5, what's the translation? It's the transformation that's happening. Horizontal translation, pi over 2 to the right. So I'm still going to do my range, my min, my max. So my min is d. What's my d in this equation? 0. And I'm going to subtract and add my amplitude. What's my amplitude in this case? 1. Horizontal translations. Does that affect my x-intercept? If I shift it to the right or left? Yeah, absolutely. But would it affect my period? The period is how wide it is, right? Technically, how long it takes till it repeats itself. But a horizontal translation would just take whatever graph you have and shift it. It wouldn't make it any wider or anything. The only thing that changes that is your b value. Now, in this case, if I wanted to find the period of this graph, I would take my b value. My b value is actually just 1, right? It's sitting in front here as a 1. And I would go period equals 2 pi divided by b, which is 1, and I get 2 pi. But if I gave you a question like this, y equals cos x minus 90 degrees, exact same question, but in degrees, right? I would still have a 1 in front. But would it make sense to go 2 pi divided by 1 and tell me it's 2 pi when the question's in degrees? No. The period we would have to do would be, what's 2 pi in degrees? 360. So we'd do 360 degrees divided by the absolute value of b, which is 1. So it would be 360 degrees. So if your c value is in degrees, your period has to be in degrees. If your c value is in radians, your period has to be in radians. Okay? And your c value will let you know, because your c value will have the degree symbol or it'll be in radian measure. So for this one, you guys need to remember that if this half was actually in with that theta, you'd have to take the b value out. It didn't change, right? Remember, if that horizontal stretch is in front and there's no brackets, you didn't take the horizontal stretch out, you have to, or your horizontal translation is going to be wrong every single time, remember? So that'll happen on your test. They'll give you one where the horizontal stretch is not taken out, and you have to remember to do it. It will happen on every single test that you have transformations on, every single time, because that's the trick, right? Okay. So they already took the half out. That's great. If it's between the sine and the theta, whether there's brackets or not, this is your b value. Okay? So we have a horizontal stretch by a factor of 2 about the x-axis. But what is my b value? Is it 2? Yep, that's a y. It's not, but it is now. It is both y. Now, is our b 2 or a half? It's a half. Our b is whatever the heck it is in the equation, right? Didn't change. So we have 30 degrees as our c value. So if I went to find the period of this graph, am I going to use 2 pi over the absolute value b or 360 over the absolute value b? 360. So in this case, it's going to be 360 degrees divided by the absolute value of a half. So that's 360 divided by a half, which is 360 times 2 over 1. So it's actually 720. Now, does that make sense? I horizontally stretched it by a factor of 2, actually, right? I know b is a half, but I horizontally stretched it by 2, so I made it wider. Is the period wider? Yeah, it's normally 360, it's now 720. Makes sense. Okay. Flip over. This is where the fun begins. Okay. So I'm going to tell you right now, you're going to want an extra sheet of paper with you. You could put them below. Actually, you have enough space. If you printed these off, you can use the bottom half, because we're not going to do each of the graphs here, because some of them are a little trickier to figure out values. So the first one that we're going to look at is we'll look at number 1. And then we'll look at 1 and 3. So 2 and 4 we'll leave for now. So they want us to determine the sine and cosine equations of the graph and determine the domain and range. Okay? I told you that that's going to get you 4 equations. It's going to be a positive sine, positive cos, negative cos. So we'll go through the coses first, and we'll do the sines after. So we're going to do the coses first for both graphs. Then we'll come back and do the sines for both graphs. So you're going to need enough room to do 4. So if you think you might not have enough room, which you might not if you're an actual bigger writer, then grab out a separate sheet of paper and put it so you don't have to squish. Up to you. Okay. So, number 1. Did the amplitude change whether it's a sine or a cos? Is the amplitude different? Did we figure it out different? No. Did we figure out the period differently, whether it was a sine or a cos? No. Did we figure out the d value? Will it be at the same height, whether it's a sine or a cos, that midline? Yeah, it's not going to change, right? If I look at the graph, that midline's still the same. It's the c value that only changes. So to find a positive sine, a negative sine, a positive cos, a negative cos, you find the amplitude, the b value, and the d value all the exact same. The only thing that changes is the c. So we're going to find the amplitude, the a value, the b value, and the d value first before we even find any of the equations. So how do I find the a value? Well, the a value is from the amplitude, correct? What is the amplitude of the first graph? It's 1. How did you figure that out quickly? It's half the distance from the min to the max, right? So how far is it from the min to the max? 2. So half of that is 1. So we have the amplitude is 1. Okay. Now the b value. So we have the period equals 2 pi over b. We agreed? Or 360 over b, depending on what our x-axis is in. All of these axes are in radians. So we'll stick with radians. So that's how you solve for the period from an equation, correct? But we're trying to get the b value from the graph. So we need the period. So what you can do is you can bring the b up and multiply it and bring the p down. So you can rearrange this to be actually b equals 2 pi over p. Because I can multiply the b up, and then it'll be times p, then I can divide the p down, and I get this equation. And this equation is helpful because I need a, b, and d, right, in order to do this equation. So the only way I can get the b value is if I figure out what the period of the graph is. What is the period of number 1? 2 pi. You can do it in a few ways, but the quickest way, I think, is to go from a max to a max, just because the max and the max are both on nice spots. So from 0 to to get from this one to this one is 0 to 2 pi. So it's a period of 2 pi. So I know the period is 2 pi. So I'm going to go b equals 2 pi over 2 pi, which is actually 1. So now I have the A. The A could be plus or minus 1. It could be positive or negative, correct? Because the amplitude is always positive, but is the A value always positive? No. Our B value has to be 1. So we have our A value. We have our B value. We need our D value. Our D value is the midline, the line that cuts the graph in half, correct? So where does this graph get cut in half horizontally? On the x-axis, right? Because it would be 1 up and 1 down, because you told me the amplitude was 1. So it actually cuts the graph in half on the x-axis, which is at y equals what? Y equals 0. So what's our D value? 0. Okay. So actually at this point, I could set up all 4 sine and cos equations. Okay? So we have A can be plus or minus 1. So that's why we're going to get 2 cos equations. One where A is positive 1, one where A is negative 1. And then we're going to get 2 sine equations, one where A is positive 1, one where A is negative 1. Do the B and D ever change? No. So let's set them up. We'll do the cos ones first. So y equals positive 1 cos, and then the B value. So 1 x something, we don't know what that something is, plus 0. Then we have y equals negative 1 cos, everything else stays the same, plus 0. Then we have y equals positive 1 sine 1 plus 0. Do I need the plus zeros at the back technically? No, but I'm going to keep them there just to prove a point. I actually don't even need the 1 in the B spot either, right? I'm leaving there to prove a point. So did we find the A, the B, and the D any different ways, whether it was a sine or a cos graph, whether I asked you to find a sine or a cos? No. Now in a question, I might ask you to find sine, the equation for sine theta where A is less than 0. So I'm asking you where A is negative 1. That's how I can force you to find a certain one. I also can force you to find a certain one by A, B, C, and D, give you 4 answers, and one of them is only the real answer, and mix coses and sines up, right? So you kind of technically have to find them all to figure it out. Or if they have all numbers, you could put it into your calculator. You can change your window to match their window and see which one matches, right? You can do that. Okay. Now, go into your calculator, clear it out, and go y equals cos x, please. So that's going to be a positive A. We drew this one yesterday. Y equals cos x. So if you have a basic y equals cos x, what is the y-intercept? Positive 1. Okay? If the y-intercept of your graph is not positive 1 on a positive cos graph, it's been shifted, right? Because if I stretch it, it'll still stay there, right? If I move it up or down, will that y-intercept still stay there? Technically, if you undo stuff, it would stay in that area. The y-intercept will at least stay on the y-axis, right? It may not stay at 1, but it'll stay on the y-axis. Okay? So would the y-intercept stay on the y-axis if I stretch it vertically? Yes. Will the y-intercept stay on the y-axis if I move it up and down? Yes. If I change the period of the graph, will the y-intercept stay on the y-axis? It actually would. What's x on the y-axis? 0. When I multiply 0 by anything, what happens? It stays the same. So the only thing that's going to move that y-intercept off the y-axis is the horizontal translation. Okay? Now, is it a maximum or a minimum on the y-axis? Look at your graph. Is it a maximum or a minimum on the y-axis? It's a maximum. So if your maximum is not on the y-axis on a positive cos graph, there's a horizontal translation. Okay? So we're going to go back to our graph up here. Is the maximum on the y-axis? Yes. So has there been a horizontal translation? No. So for a positive cos, I could just go plus 0. Or I could go minus 0. So I'm looking literally for the maximum on the y-axis. If the maximum is on the y-axis, we're golden, right? So maximum on the y-axis, we have no horizontal translation. Now go into your calculator and change it to be negative cos x. So now our a value is going to be negative. Negative cos x. So we had a maximum on the y-intercept when it was a positive cos x. What do we have on the y-axis when it's a negative cos? A min. How would that happen? What does the negative value in a do? Reflects it in the x-axis. So it made it max now be a min. So to find the horizontal translation of a negative cos, we look where the heck the mins are. If the min is on the y-axis, no horizontal translation. If the min is not on the y-axis, it's been moved. Okay? If the max is on the y-axis, I'm assuming the min is not on the y-axis. So we're going to have a movement. Okay? Where is our minimum? Well, here or here. Now, if one of them is closer, they usually use the closer one. Okay? Are either of these closer than the other one? No. So which one's correct? The one they give you, right? That would be the one that's correct. They might say x plus c. Well, then you know it's the one that moved to the left. If they do x minus c in their equation, then you know it's the one that moved to the right. That's the way they can force you to one way. Now, remember, the min was on the y-axis, correct? So if we choose this one, we're saying it's moving to the right pi. If we choose this one, we're saying it's moving to the left pi because we're moving from the y-axis, right? We moved it, right? Moved it. So could we use either of those and be correct? Yeah. Which one do you want to use? To the right or to the left? To the right. Someone said left. You can do whatever you want. You'd still be right. So right, I'd go minus pi. Left, I'd go plus pi. Both of those would work, actually. It would make the exact same graph. Okay? So if you typed the first equation in or the second equation in, you'd actually still get that same graph. Okay? The signs we'll do in a second. They're a bit harder to see. So when we're finding the horizontal translation of a positive cos, we look for the max, how far away it is from the y-axis. Okay? I want to write that as a little side note. I'm going to write it up here. So horizontal translation. Wow, this is looking super messy. C value. Whoa, this is terrible. See? It's lagging and it's making this not look like that's value. Sorry, I can't make it to not connect itself. Look to see how far the max is away from the y-axis. When a is greater than 0, right? When a is less than 0, you look to see how far the min is from the y-axis. So this is for cos. Make sense? So literally for the sine graphs are extremely close, we just don't have the c values. We agree? The a was found the same, the b was found the same, the d was found the same. So next we're going to look at number 3. We'll come back to the sines later. If I do sine and cos at the same time, I lose you all. You'll be like, oh, that's easy, and then throw the sign, and then it's like too much information is put in, and it all just falls out onto the floor in a mess. Okay. So number 3, what is my amplitude for number 3? What's the distance from the min to the max? 2. So what's half of that? 1. So my amplitude is 1. So my A is equal to plus or minus 1. Some people say, well, how do I know which one to use? Well, if they say when A is less than 0, they're telling you to use negative. Okay? Now the B value has to be in 2 pi because the x-axis is in radians. So P equals 2 pi over B, but B equals 2 pi over P as well. So I need to find the period of this graph. I need to figure out how long it takes to repeat itself. Then I can get my B value. How long does it take to repeat itself on this graph? Looks like 2 pi. If I start on this y-axis here, I go past a max, past a min, back to that same height. Looks like 2 pi. Now on diplomas, if it's like not completely clear, they'll like label some of the points, or they'll tell you what the max point is and what the min point is. So they make it accurate for you rather than they'll never make you like, it looks like possibly could be 2 pi. Okay, you'll never say that on a diploma. So in this case, it's going to be 2 pi over 2 pi. The period's 2 pi. So it's 1 again. Is B always 1? No. The D value, these are just the easier graphs that we're doing first. What's the D value? What's the midline? Where does this graph cut in half horizontally? At y equals 0. Oops. And that midline is important to draw when we do sine and cos, when we do the sine graphs. You're going to need that midline drawn when you do the sine graphs, just so you know. It's a really terribly drawn one, but nonetheless. So it's at 0. So when I go to write out my equations, I'm going to have y equals positive cos, b is 1, x we don't know, plus 0. Y equals negative cos, 1, x we don't know, plus 0. Y equals positive sine, 1, x not sure, plus 0. So nothing changed on all those. The only thing that changes is the horizontal shift, right? For a positive cos, we're going to look to see how far the max is away from the y-intercept. On the y-axis, sorry, not y-intercept. How far the max is away from the y-axis. Because normally on a normal, plain old y equals cos graph, max is on the y-axis, right? So if max isn't on the y-axis, it's been horizontally translated somewhere because the horizontal stretch does not affect only that point, because that's the only place where x is 0. Okay? So let's go back up here. Where's the closest maximum? I'll draw the median line back after. Where's the closest max? The one to the right. Correct. Now, if you follow it down, like I said, they'd have to actually give you what the maximum value is on this one because we're really going to be guessing here because it's really tiny little lines. But let's pretend they actually label it. So it would be, let's say it's here. So 3 dashes away from pi. Okay? What the heck value is that? How do I figure out what the ticks are? Remember yesterday I showed you? How do you figure out how the ticks are? Yeah. Yes. So you count how many ticks up to pi. It's always up to pi, right? Doesn't matter if you have 2 pi or 4 pi, whatever. It's always the ticks up to pi. So how many ticks are there? There's 12. So the first tick would be pi over 12, 2 pi over 12, 3 pi over 12, 4 pi over 12, 5 pi over 12, 6 pi over 12, 7 pi over 12, 8 pi over 12. This one would be 9 pi over 12, which reduces to 3 pi over 4. Now we were on the y-axis. We're now over here. Which way did we move? Right. So we're going to actually have x minus 3 pi over 4 for the positive cos. Remember, if we're putting in a horizontal translation, we have to have that in brackets because x has to equal 1. It has to have a 1 in front of it, and it does right now. Technically, it still has 1 in front of it the other way, but whatever. Won't stay that way. For negative cos, we look for the closest, put those two together, what? Min. So the closest min is on the left. Now it's going to be, let's say there. So 3 ticks away, but negative. So it's going to be negative 3 pi over 12, which reduces to negative pi over 4. We used to be on the y-axis. We're now on the left. So when we fill it in, it's going to be plus pi over 4. Don't worry about the signs. We will come back to them. We'll come back to them tomorrow because I'm going to make you do a whole bunch of homework on coses tonight. And we'll come back tomorrow and we'll start the signs. It's really easy to do once you have the coses really, really well. If not, it gets like all mumbo jumbo and we don't want that. Okay, so next page. So we're coming back to those. Don't fret. I want you to go ahead a few. I want you to go ahead to like this example. I like it because it is larger instead of tiny, and then you can see more things. So we're going to go ahead to example 3. So we want to determine the equation in terms of sine and cos. So exactly what we did. So it's about right there. Should be. It didn't show up on your, it's right. Oh my God. Well, that's a really good one. Oh my gosh. B. Why? Why? I don't even know why I question it. Sure, of course it did that, right? Because that's how we roll. Okay, B. I like B because you don't have A and I don't really want you to try. B. B is wonderful. It could be any, the C value could be any max and any min, but they usually pick the closest. They'll usually say the smallest translation away from the y-axis so that they can consistently pick you one. But they could pick the next max over too, right? Technically. Okay. So determine 4 different equations for the graph that you actually have. Yay. So the amplitude doesn't change whether it's a cos or a sine. What's my amplitude? What's the difference? So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So what's my amplitude? 10? 5. So my A could be plus or minus 5. How long till this graph repeats itself? Well, it's pi to here, right? So this would be pi over 4, because we're going to go from here, past a min, past a max, back to here. So 4 ticks are pi. 4 more ticks would be 2 pi. It's another 2 pi one. They're not all 2 pi. It just happens to be that I'm picking all the ones that are 2 pi. I wouldn't have. This one wouldn't have. Would it have been? No. This one would have been 4 pi. But you don't have it. So B equals 2 pi divided by 2 pi, and it's 1 again, which is not always the case, although it seems like it. It is not. It wouldn't have been on the other one. It would have been 2 pi divided by 4 pi, which would have actually been a half. Okay? Now my D is not 0 this time. Yay! What's my D? 1, because I would have to go 1, 2, 3, 4, 5. Yay, it's here. So if I count my amplitude down, 1, 2, 3, 4, 5, they should meet at the same place. They meet at y equals 1. So D is 1. We start writing out all these random equations. So we're going to get y equals positive 5 cos 1 again, x plus 1. Y equals negative 5 cos 1 x plus 1. Y equals negative or positive 5 sine, which we're doing tomorrow, 1 x plus 1. Y equals negative 5 sine 1 x plus 1. We agree? So we'll do the coses today. Positive cos. Where's the closest positive cos we're going to look at? The one on the left, the max on the left, right? So it's here. How much is each tick worth? A quarter. Because to pi I have 1, 2, 3, 4. So this would be negative pi over 4. This would be negative 2 pi over 4, technically, which is negative pi over 2. So we move to the left. So we're actually going to put in plus pi over 2. Remember, you're moving from the y-axis. The closest min is positive pi over 2. So we move to the right pi over 2. So we're going to put minus pi over 2. Not hard, right? Not too bad. Seems overwhelming at first, but it really isn't that bad. Okay? So I'm going to give you a whole bunch of questions to work on. Yay!